Now, today's topic is 3D printing, and I'm sure you all have heard about it, maybe seen some of it, and maybe possibly tried some of it yourself. Due to the fast development of 3D printers, 3D scanners, and 3D modeling software, 3D printing is becoming more and more interesting and affordable for personal users. Today's presentation will give you a better understanding of exactly what 3D printing is, how it is used commercially and personally, and how you can get involved with it. Ultimaker is a company that specializes in 3D printing with its headquarters in Utrecht, the Netherlands. They employ about 400 people with subsidiaries in Boston, New York, Memphis, and Singapore. Ultimaker was one of the first companies to make 3D printing available or accessible to the greater public and is one of the market leaders in desktop 3D printing. They developed a software application called Cura that enables you to print 3D objects. Cura is open source software and is available for free. Now, Build Volume is a South African reseller of Ultimaker's products to both the commercial and personal markets, with offices in Pretoria, Somerset West, and Mossel Bay. They assisted me to find someone knowledgeable about 3D printing to do today's presentation. So thank you to Don Vermeulen, the CEO of Build Volume, and Tiaan van Rensburg, the Relations Officer, for your assistance. Tiaan is based here in Somerset West at their offices in Park de Links Office Park, and he joined us. He is here in this Zoom meeting. You can see his name there is called Relations Officer. So welcome, Tiaan. Patrick Roeffer is the Channel Development Manager for Europe, for Eastern Europe, Middle East and Africa of Ultimaker. He started his career in 2D printing and wide format printing, both technically and commercially, for companies like HP and Xerox. He has been with Ultimaker for longer than 6 years. Patrick is Dutch and he lives with his wife and 2 daughters in a small village called Druten, 20 kilometers west of the German border, next to the Vaal River. And that's where he joins us today in the Zoom meeting. So a warm welcome to you, Patrick, and I'm handing it over to you.
Well, thank you first of all for the possibility to join you and explain you a little bit about 3D printing. 3D printing, I kept it quite simple in a way that I explain from the start what 3D printing is and build it a little bit up to what it means to companies, what it means to everybody. Since I don't know the state of everybody on how far they are with the knowledge of 3D printing itself. So what is 3D printing? 3D printing is a manufacturing process that creates a physical object from a digital model file. So the technology works by adding layer upon layer of material to build up a complete object. So as you can imagine, you like with 2D printing, you have a piece of paper, and that's the same way. So you make one layer and then you put another layer on top of it, and so on and so on, and that builds in the end the object of 3D printing. So what are the different 3D printing technologies? The different ones are SLA printing, SLS printing, and FFF printing. Selective laser sintering and stereolithography is not where I'm going to talk about it to you, because that are way professional parts of 3D printing with large expensive machines, which is not really suitable most of the time for personal use. So I'm not going in too deep on that. So I'm mostly going to talk to you about FFF 3D printing, which has a wide range of materials and machines, getting from, let's say, if I'm used to euros, so I will talk in euros instead of rand. From, let's say, 250 euros ongoing to 200,000 euros, depending on what exactly you would want. So it's the most easy and yeah, easy to learn also way of 3D printing. So what is then specifically FFF 3D printing? The FFS is fused filament production. It produces a process of extruding a string of material, which is called filament. And this filament is then molten in a extruder and is placed on a glass plate where you can then build up the model, so to say. So you see that in the drawings below. You see it building up until the complete letter U is coming on. So the nozzle has a lot of heat and melts the thick filament into a smaller filament material, and then it sticks together on the build plate. Then commonly you see in the market that some people will refer to it as FDM printing, some people will say FFF, but in fact that's the same thing. So if somebody talks about FDM, which is fused deposition modeling, or FFF, which is fused filament fabrication, they are exactly the same thing, but because of branding and paid patents in the past, this is two ways of mentioning it, but it's completely the same. So how does it work? As we saw earlier, the 3D printing process involves building up layer on layer of molten plastic to create the object. That's what you see also on this picture. As each layer sets, the next layer is printed on top, and the object is built up that way. So you have to see this goes millimeter by millimeter. So some prints can take up to many hours before it's ready. And you can also make prints in a couple of minutes, but really depending on what you want to print and in what quality you want to print it. So to make a 3D print, there's a digital file. So if you've drawn let's say this would be a small elephant. If you would draw that in a CAD program, that can be Fusion 3D, that can be AutoCAD, SolidWorks, more simpler 3D programs, whatever 3D CAD program there is, you can make a model out of it. You will save that model as an STL file, which is common in the CAD world. And that STL file needs to be translated in something what the printer understands. So the printer will get a code which is called G-code. And the G-code is nothing more than a translation file where it puts the translation of the model into layers that the printer can understand with the movement it has to make the model. You see that here. The file is essentially contains coordinates to guide the printer's movement, both horizontally and vertically. And you got with the rods that you see in the machine, you have an X, Y, and Z axis where the machine builds up and the material in. The layers can be of different thickness so that it gets faster, or if you have smaller layer thickness, then it's getting more precise and you have a more smooth cover of this, like you see here. And the elephant, what builds up there is quite nice and smooth on the outside. So what are the perceived benefits of 3D printing? The first use of it is bringing new ideas to life. So if you have an idea to make something or to solve a problem, then it's quite easy in 3D printing together with the easy to use CAD modeling software to make your idea. And even kids are doing this in large scale. For example, here in the Netherlands, 3D printers are sold to schools as a part of a project, and then they learn how to solve problems themselves. So we, let's say, older people, and I'm counting myself to it as being 53 years old, we are mostly thinking in CNC milling and that kind of thing. So you have a block and you cut out materials, and then you are stuck to certain engineering rules, what you can do. But a kid doesn't know those rules. So that means with additive manufacturing, he's just thinking about solving the problem and then try to print it and then tries to use it as with the purpose that it's meant for. And if that doesn't work, then he just makes another design and tries again. That's the power of 3D printing. So anybody can start using it. The more there's also for companies, if you look into that, there's a more effective way of making jigs, tools, etc. So you can imagine the lower amount of tools that you need to make. So if you have a one-on-one tool, a special tool, if you have low series of tools, let's say 10, 20, 50, a normal processing and prototyping, etc., would cost a lot of money. With 3D printing, that's less and less important. So you can make and iterate as fast and as many as you want. And yeah, the costs are not really there. So you see a lot of tools in factories that they nowadays can be produced on a 3D printer and be used as for the purpose they are made for. That's also the third one, as I said, more efficient for small batch production. So what are essentially the uses in 3D printing? Most of it is the biggest market there is prototyping. Second market there is production tools, and more when we see that the printers itself are getting more professional and more easy to use, the workflow around it is made more easy. Then you see also that people are making end-use parts, and so they customize a lot instead of building whole series. What are the opportunities for 3D printing? It gives you a faster time to market, it increases the uptime, the operational efficiency will improve and develop future, you can develop a future-ready organization, because this is part of the so-called Industry 4.0 everybody always talks about. And in operational scales and opportunities, you see that it reduced the product development time and cost, because you can do it yourself. You're not need to make a mold and redo the mold and iterate, which can take months. But you can shorten that to maybe weeks or days, even if necessary. So that also shortens your time to market. It enables rapid design iterations. As I've already said. Minimizes delivery delays. You can imagine like the big ship, the Ever Given, was in the Suez Canal. There are a lot of people who were hurt by the parts that were on that ship or any other ship waiting behind it. In that time, you also saw that people were starting to make spare parts on a 3D printer just to get through the time that they need to get the machine running, because the parts were not there because they were stuck in the channel of the Suez. Increased productivity in engineering, design, production, quality control, ergonomics of manufacturing aids. I will show you later on what that means in daily practice with some companies. It reduces operational cost. It reduces waste, because it's an additive process. Instead of that you take away material and you have a lot of wastage, you build up with material. So there's less waste and scrap after to rework. It improves product margins. It improves uptime for factories. The ROI is determined for digital transformation with additive manufacturing, diversification against competition, etc. I don't think the last ones are that important to really say because I already explained it in the first two. What applications can you think of? In product development, you can think of mock-up models, concept prototypes, functional prototypes. In the manufacturing, you see that they make safety tools out of it, transport tools, production tools, maintenance tools, assembly tools. All kinds of tools are made in a production plant for cars, for bottles of beer, for the perfume industry. You mentioned it, all industries are part of this 3D printing future. Then you have end-use parts, so for external replacement. So imagine some things you need to mold, and then when you mold it, you need at least 5,000 parts of it or something to make it even, payable. And on the end of a lifetime of a product, you see that those parts are still there and are being wasted. And all the time in the warehouse costs also a lot of money. So if you can print it and just print it when you need it, it will be a lot cheaper than keeping all those things in a warehouse. Also in medical, you see that they use it for educational models, so to print organs, to print anatomical models. Prosthetics is a great use of it. So we have, for example, also doctors' organizations like Doctors Without Frontiers, I think they are called. They are making prosthetics in Sierra Leone for people over there. And the thing is that these prosthetics are really cheap to make. So if you have a really good quality prosthetic, then it costs a lot of money, especially with kids. They grow, so each time you need to adjust the prosthetic. And that's too much of money. So often you see that kids are only getting good prosthetics when they are at a later stage and later age. And with this, we can build prosthetics which cost maybe only 15 euros. And then you can easily help anybody there. In research stage, there are a lot of other stuff, but that is really a difficult one because there are a lot of rules around materials which are getting into the body, etc. So that's a thing that is on research at the moment. I said you have a printer, a 3D printer that has an extruder. You can also have a printer that has two extruders. So with two extruders, it's even more versatile and more simple to build complex models. So you see here a kind of a sphere, and this sphere is built with this white material, which is support material. And the nice thing of this support material is that when you put it in water, it melts. And when it melts away, you get this model, which you never could have made in any other way than with 3D printing. You can use it with color coding, that you print one or more colors. If you need a wear indication of a part that you want to see. Hard-soft combinations of materials. Here you see an example of text integration where they printed in the text of the part. Wear resistance by two stiffness, two different materials that create a lot of stiffness in the material. So during the product life cycle, there are points where you can use 3D printing, and there are clearly points also where you cannot use it. So where you can use it is for concept modeling. You can use it for the visual prototyping and also for the functional prototyping. But this is now being created that it gets better and better because of combination of materials and more research that we do. And you can also use it as a production tool in the mass production facility. And if you create low volume specialized products, then 3D printing could also be a production method. If you think that 3D printing ever will um, substitute mass production, that will not be the case. So we are not expecting that if you produce 1 million bottles, that this bottle will be 3D printed in the future if you need 1 million, because there's a problem with the speed, there's a problem with costs at that point. So then you go back to molding or any other product facility, which is then cheaper. Then in the end, where it also can be interesting is that you can create spare parts production. So what you also see for those people who watch programs on Discovery, like Wheeler Dealers or something where they are rebuilding a car, then sometimes you see that some parts are not available anymore. So with 3D printing, you could make those parts yourself, and in this way create value for this old car, and that it works and runs again. But you can also imagine that you don't want to keep 5,000 parts on stock, which are molded to make it more interesting, when you just need 2, 3, 4, or 5 parts to be accessible. So what is our company vision? The company vision is to accelerate the world's transition to local digital manufacturing. And you would think, okay, but you are a 3D printing company, so why is this big thing a company mission for you? So that is because of this. Today you see that in a factory we are mass producing things. So everything you see going to, especially from a Europe perspective, you see that a lot of things are going to China because it's a lot of cheaper to produce there, etc., etc. It's mass produced, then we come with trucks, boats, planes, etc. We transport and move it back to the client location. So what you also could think of is that in the future, you only build something when you need it. And that means that we kind of have a digital factory. So instead of making it in mass, we can also say we can iterate everything, that it's not specifically a complete set of products which is mass produced, but that we create it when we need it. And then on the location where the customer is. So the customer buys a 3D printer, and you see that already happening in Germany. There's a company who's making the machines for food and beverage industries. But the food and beverage industry needs also help with parts which go down on machines. And when they can do that themselves, their production is much quicker. This is a typical 3D printing workflow. So you start up here in the corner, you choose your CAD software which you want a 3D model in. There's a lot of samples there. Then if you saved it as an STL, you open it in Cura, and most of the time there's also connection between Cura and the model software. At that point, the so-called model is sliced or made into the G-code, which the printer understands. Then you say to it what material we want to have it, how the quality needs to be, how strong it needs to be, etc., etc. And at that point, you can send it to the printer. And in this case, I don't talk about digital factory because that's not applicable for personal people. You 3D print it, you remove it from the 3D printer, then you need some post-processing. So if you want to smoothen the outside of the material, that's a possibility. If there are support pieces in it that you need to remove, like this water-soluble material, then you can take it out. And after that, you can use the part. Probably you want to optimize it and set new requirements to it. And at that point, the thing starts over and you can iterate. Not going too deep to this. This is our top model because otherwise it gets too commercial. But we made a machine that this is the actual 3D printer in the middle, but we took care that you can put more material spools in it, and that you can select a material that and automatically is transported into the machine. And the top cover here takes care of all kinds of filtering of keep it in a certain heat inside the machine, but also to take care of a lot of how you say that volatile air, etc. If you use certain materials, because normally if you use the normal standard materials for home use, there's no worry that it's problematic to you. Building materials, PLA is the most used material. It's easy to print for everybody. If you start printing for yourself, always start with PLA because it's the most easiest material. ABS I would not recommend, especially for home use, because that material will stink in the printer when it burns a little bit. It's also not as easy to print off because it can get warping. So if you want to have a flat layer on the other side, sometimes it goes up and deforms a little bit. So it's not the most easy material. So for home use, I would recommend PLA, maybe CPE. The other ones are more industrial materials that industries will use. What also can be used as a TPU, that's a soft material. So that gives a high impact strength, it's flexible. Tough PLA is a safe material that has a higher stiffness than ABS, and you can use it instead of ABS. And polypropylene is also available for us. And outside of this, there's a lot of more materials. So a lot of chemical companies are making filaments. Together with those companies, we make profiles for the printers, so it's safe and easy to use in our printers. PVA is the water-soluble material, where I said that you need a support material sometimes, because if you print this, then it would go down. You cannot print in the air, of course, so then sometimes you need support to print it. This is water soluble. We also have a thing called breakaway material, which is also commonly used. And this is easy to break away from the model. So if you afterwards take it, you break it off, then you get the normal result you want. So how do companies use this? This is an example from L'Oreal, cosmetic production lines. They needed rubber grippers, and they needed to be replaced monthly. There is a lot of lead time savings here. 99% of reduction of costs are done. And you can see the lead time of the part for L'Oreal went back from 30 days to 0.02 days. You can imagine that also in euros or rands, that's an incredible amount of costs. In the same way, L'Oreal made this. This is a kind of a blower what they use in there. If you would need to make this, I think this is really impossible almost to engineer, and you almost need a 3D printer to do this because it's, as said, unmachinable. KLM, Dutch Airlines, you probably know. In the maintenance department, they are making these kind of plugs, and these kind of plugs go into the wheels for masking when they want to paint the wheels. And they used €8 masking tape per rim, so that's 200,000 euros of masking tape a year. And with those plugs they printed, they cost 0.33 euro cents. And so the savings are 200,000 euros a year just on a simple thing like these plugs. We came up with them, so we went into the factory and we said, okay, this is our problem, they said, and yeah, what can you do? How can you make it? Same thing for KLM. These are the latch covers, which they use also for masking and maintenance protection of covers, etc. Normally, they would buy them at 34,000 per slide latch. The replacement cost of a 3D print is only 20 to 30 euros. So imagine also there what you save there. Then another case is the Heineken. You all know Heineken from its beer. I leave it in the middle if you like it or not. That's a personal choice. But they had a problem with a can pusher, and when that can pusher broke down, then the machine runs into a mess, and it takes them 2 to 3 hours to cover that. So together with the engineers at Heineken, we said, okay, how can we solve that? So we came up with the part, with the red-white part, which you see here, where it also, we build in a kind of a wear indication. So when the white comes through, then they know they need to replace this part. They stop the machine for 10 minutes, they replace it, and they can produce on again. So this also, next to the fact that it's already the modification and what it saves there, you can also imagine if you win 2 or 3 hours of beer producing, what that means in a total value of money. Interesting websites to look like for you would be our website. You can download free Cura software to try there. We also have an Ultimaker community where people help each other as customers of Ultimaker. Also customers of Cura, they find a place there. So not necessarily people who only build or print with an Ultimaker, but also other brands. They are going there to get info on the Cura software. Then there's the website of Build Volume. Ultimaker is maybe not the brand that you would immediately buy for personal use, because we are a little bit more expensive. But there are a lot of brands also in the Build Volume shop where you can perfectly start with, and then when you get more interest and you really need the top level machines, then you can always go to the level that it's more interesting for our community, so to say. And then you see, I put here a Thingiverse. That's also not a website from us, but here you can see some free STL files to print. So you can download STL files from there for a basket, for like the little elephant, for example, I showed earlier. But also everything you can imagine, like a toothpaste, a clamp, whatever things you might think could be in handy, you can get it out there and then you can print it. One warning, not all prints there are checked if they are good. So that means that sometimes if you're printing, they go wrong, or you see that it's not as perfect as it would be. Yeah, but then you need to iterate it yourself in an engineering program. Another one is umagine.com. That's used to be is the website of one of the old owners of Ultimaker, and the STL files up there should be checked that they are good to go with an Ultimaker at least. So you can also get free STL files there, from little rockets to cars where you can play with, etc. Questions? I saw some questions popping up in the chat, so I will look into there.
Patrick, there are a few questions there. Well, it was absorbing to listen to you. Thank you. But yeah, let's go through the questions. I think the first one there is, what is the speed relativity, soft to hard, example, carpet to bottle? and Wilson asked that. Do you understand the question?
Not exactly. I can the speed relative. If you talk about the quality of what you print, then yeah, it can be different from a few minutes for a small piece. If you have a more expensive piece, it can take up to 24, 25 hours, and there are even printers who can print meters by meters. Yeah, then you talk about maybe 3, 4, 5 days. But I don't know exactly what she means with soft to hard or carpet to bottle.
And you're welcome to unmute and just explain your question.
Yes, I just wondered while you were talking, you know, what sort of time frame are we looking at here? Does a soft piece of equipment take shorter or longer? And, you know, I can imagine something metal or glass would probably take longer to build up than something soft, maybe. That was where the question was coming from.
Yeah, let's say it is not specifically related to the material, it's more related to quality.
Aha.
So if you want to print TPU, for example, which is a soft material, and then and or you compare that to ABS or any other material, then you can print it at a certain speed, and the quality and the amount of strength you want into the print relates to how long this will take. So, and it's yeah, and if you talk about glass and metal, you know, metal is something entirely different. So metal printing is done by machines over, most of the time, 100,000 euros, and not by these printers. Although there is a filament material like metal filament, copper filament, which you can print through an Ultimaker or through some other printers. Not every printer is suited for that. But then you need to have a good process to sinter the material, sinter the plastic out, and that it combines to a hard metal. So that is not for personal use. That's really going, so it goes into industrial processes, and that's even for companies. It's at this moment still quite hard to produce very precise metal objects.
Thanks.
Let alone glass. That's even more difficult.
Thank you.
Good. Patrick, the next question from Derek. For how long has 3D printing technology been around, and when did it first become available to general consumers?
It started in the 80s, 1980s. Then you had the first printing companies, 3D printing companies, making their machines, and then you're going more into the higher end machines. So then printing costs really 60,000 to 1 million euros. And it was really covered with patents, etc. So you know, that was really difficult. And during this time, there were also professors. There was one guy who made a kind of a personal one that melted this plastic filament. And when, for example, Ultimaker started, that was in 2010. So we are more or less a 10-year-old company. Then you saw that there were all kinds of university people who started to find a way to share knowledge about 3D printing for people. And so since 2010, since 2011, you see that the desktop models came to the market, which were more affordable to everybody. And during from then to now, you see also that it improves, that it's easier for everybody to print. And from now on, you really have the simple ones at 250, 300, where you mostly can print PLA, but not the more sophisticated models in. But for some home things, that's more than enough. So if you want ever to buy a 3D printer, don't think I can print everything with it. Then the small machines are used to print with PLA plastics. That's easy to do at home. So don't think I'm going to make everything what is needed for my home and I can do everything now. That's not where 3D printing is about, and that's also yeah, what people learn nowadays, that it's nice to have. If it's a hobby for you, then it can be very nice, but it's not that it solves all problems.
Just in relation to that, Derek is also asking, what's the life expectancy of a 3D printer, and what's the next big development that you expect in relation to 3D printing?
Well, the life expectancy of a 3D printer lies more in the software around it. If you can still use the software, it's like, yeah, the computer is still worse. So if you have a laptop and there's Microsoft software on it or an Apple software on it, then by updating the software, etc., the machine goes out of date. So that's mostly you see with that it's 3 years of a laptop. But 3D printing, when it's not connected to the network, so to say, and you can use the USB stick to put the model on and put it into a machine, then technically such a machine is easy to maintain. You can easily replace the parts in it. Then you can maybe go up to 5 years, 6 years, 10 years. We have printers that we sold in the beginning that are still running. And so there's no real limitation as long as you replace the moving parts. If you connect it with software to the network, etc., then I would say that 3 to 5 years is the economic, yeah, the technical expectation. Economically, it's a different thing. So if you talk about companies, then I would say that after 3 years, there's new technology that is better, can go further, can do more materials, etc.
Yes, Patrick, then also Anne asked, you refer to all the cost savings from especially the commercial companies. Now, she's asking a commercial question. Do you think they pass on these marvelous cost savings?
That will be per company different, of course, but I think the most companies that have the cost savings, that they keep that as profit to themselves, because that's most of the time. Depends also a little bit on the branch you are in. So if you are in a branch that is very competitive, then and there's not a lot of difference in the different products of the competitors, then they might give it through to the customer. But if you have a product that is really yeah, different to the rest, then I think they take it for themselves. So then it's more profit for the company.
Angela,
Sorry,
also...
that's just a bit frivolous.
Sorry, Anne, just say again.
I'm sorry, the question was perhaps a bit frivolous.
Okay. Angela say, or just suggest that there must be environmental advantages as well. Less waste in the production, less transportation required. So indirectly, a lot of savings from an environment point of view.
Yeah, yeah. There are a few things about 3D printing. So it's not all environmental friendly. So we still use plastics. But what you can do, and that's what, for example, KLM Airlines is doing, they take the plastic bottles, etc., what people drank in the airplane, they take that into their factory, they collect this waste, and they shred it, and they make their own filaments out of it. And from this filament, these plugs, which I showed you, they are produced from that. So then you see they recycle it in that way. So that's one nice thing to have. But you can also imagine that where certain tools were made in the past, then you need a specialty tool for in a factory, like Volkswagen, for example. Volkswagen needs certain help, and that's our one-off tools. They used to let it produce somewhere else. So that means it went out of the factory, then they needed a mold, and molding of a single thing was also cheaper in China. So for that special tool, it went all the way to China, came back again, etc., etc. So you can imagine that is a lot of transport, waste of good fuel, etc. And you can also do that by yourself, by having the 3D printer, by having software, and by educating people. And that's also what we do when we sell 3D printers. We give a whole education around it, and we teach people in a factory how to use it, what they can do. And we also want commitment from those people that they really want to learn. We don't like to sell a machine into a company and that they don't use it, because then we sold something, but it doesn't add up to our mission, which we have. So we want them really to produce things with it, that we create less transportation, that we create less waste, etc., etc. So that's one of the things that we have in mind.
Okay, and a question from Bernard. I've got a similar question. What cannot be 3D printed? In other words, can metal items, for instance, be printed? Can I do?
Yeah, the metal items can be printed. It's not recommendable for personal use, but if you need precision materials on metal, we have workflow on it, and together with because you also need sintering ovens, etc., to really bind the materials and make it as good as a part which was created with CNC milling, for example. But it can be as accurate, it can be as tough. The nice thing is you can make more organic forms out of it. So what we also see that some companies, one name of a company is Andritz Kaiser. They had a lot of metal parts, and they find a substitute in a plastic. I said, okay, if the wear resistance, etc., is good, we can also use this plastic, and the material is also a lot lighter. So we need to think, I think, more in what can be a solution for a part, instead of going from, I want a metal part. You need to look at what is the purpose of this part, and then choose what is best to produce it from. Does it need to be light? Does it need to be strong? Because we have plastics that are maybe stronger and more versatile than metal, and sometimes you really need the metal, and it's printable. So what is not printable, it depends also a little bit on what you call printing, and because nowadays everything is called printing. So 3D printed houses, that's what you see from concrete. So in fact, that's a concrete mixer, but then by software we create that it can put a certain form into it, but it remains a concrete mixer. And for me, but that's my personal opinion about it. But you can think about, glass printing is not there, so I don't see really glass printing. You can, the technical things are mostly there, but it's not always good to print. So for example, with medical use or with food safety, there are things that can be printed technically, but then it needs to go to a process of the FDA, etc., to use it in a machinery, etc. Because a printing process can also have some parts which is coming loose from the metal nozzle. So that's a little bit tricky.
Helga, I think your question was also answered. If it's not so, you're welcome to unmute and just add to the question. Judy is asking, if you would like to make a casing for electronics, what considerations are there? Are there maybe static problems that can result from that?
Yeah, sometimes it's possible that there are some static problems with it, but there is also material that covers that problem. So there are materials, filaments, certain plastics that are anti-static, and you can print them too. So that's why we always say, when we talk to customers, we ask for what do you want to make? So what is the product you want to do? What properties does this product need to have? And that gives a demand on a certain material. Instead of thinking, I'm going to build this from that material, you just need to think, okay, I need a product, and these are the things that I want from this product. So what material gives me that possibility? So you have anti-static material to print for casings of electronics when that is a problem. But you can also use normal PLA. We have a company called Unidagrid. They go into the Schiphol airport, for example. Then you have these dustbins, and yeah, when they are full, you want them replaced. So they made sensors in it. And they also print with our machines. They print the casings around these sensors so that it's also safe and strong for the sensor. And then people know when the dustbins are full, and they can collect the dust and all the wastage out of it.
Good. Helga, I saw you did unmute. Do you want to add something to your question?
Sorry, here we are. What I meant is, can you have a material that has absolutely no plastics in it, like pure metal, pure cement, or is there a component of plastics in everything?
If you want to print with FFF, so the technology that we have, there's always a plastic in it. That's a kind of a carrier. And then you print the filament is then consists of a plastic and the metal material, and then you put it in an oven, and then it will centering oven, and then it will center and becomes a complete metal product. You can also have the metal printers. They are not foreseen with plastics, but then you talk about machines that are more than 200,000 until millions of euros. Glass is mostly not printed at this point, so it's that's molded. I never seen commercially glass really put to the 3D printer.
And what would you do with cement? You can't melt out the plastic there.
In the metal printing, you don't have plastics in it. But if you have a machine like we have, so the fused filament, so that what is reachable for you to buy, then there's always a plastic material connected to the metal. So the metal filament, BASF, for example, has a metal filament that's called 316L. That is also it needs to be melted by the extruder, so that means it needs to have plastic in it, and then you can build it, and then afterwards in a sintering oven, the plastic is really molten out of it. Then the metal object shrinks to the form and to the measurements that you wanted out of it, because that's software related, and then you have a full metal object. But there is also metal printing from metal powder, and there's a new technology also what I seen to market, but they didn't sell that a lot. Then it's a kind of a filament which is pure metal, and that's kind of a welding thing, and with laser sintering, then you build it like that, and there's no plastics to it. But those are very expensive machines.
Thank you.
Thanks, Patrick. Just the last two questions that we can briefly look at. The one from Bernard: could teeth, body organs be printed in the future?
Yes, I know already examples from doctors that printed with, and it's not with a standard 3D printing, then you have also a little bit more expensive machines. For example, if you peak with certain, print with certain kind of thing like Peak, and they use it for a skull when it's not there. There are outside body organs, there are bioprinters already starting up, but it's still in the university phase, so to say, that people are researching it. It's not really commercially scale that you say, okay, let's everybody who misses an ear, we print an ear and we fix it, and that's that. So that's also experimental, most of it. Where you see the most progression is in the dental area, where you see that they do all kinds of materials that are used for at night for sleeping, that people put a kind of a bit in their mouth. I don't know the maybe retainer or something to keep the teeth safe from scratching when you are asleep. So those things are made. The models to make teeth out are made in 3D printing already. So I foresee that it will be done in the future, but not at a big scale at this moment.
Good. Final question from Derek. Is it possible to just scan and reproduce an item instead of designing it with CAD software?
You can combine a scanner with scanner software and a printer, but imagine that when you scan something, then it's done in pixels. And a pixel is not ready to use for printing 3D. And so what you always need is a good software. And 9 out of 10 times at this moment, you see that when you scan something, you still need to iterate it or make it better in CAD software, because sometimes they miss the pixel, etc. And that will also, you will also see that back in the quality of the print. So it's not that like a copy machine with 2D printing that you just take the file or the paper and then you put it on the glass plate, close, print, or copy, and that the same comes out. That's not possible at this moment. Maybe in the future, but not for now.
Thank you. Thanks to all the questions. Patrick, thank you very much. You really explained it very well. I could follow everything, and I'm sure most you could see from the questions, people really enjoyed it and found it very interesting. And you also stuck to your guarantee that there's no major commercials in your presentation. Moving on to our next section, the thing that we refer to as I didn't know I can do that. Now, many of us have old laptops or desktops which tend to become slower and slower over time. Especially when starting up, it seems that it takes much longer than before to get going. Now, there could be many possible reasons for that. And in today's I Didn't Know I Can Do That series, Derek van Eeren will introduce us to a method that will speed up your old computer. This method will also add additional storage to your system and give it a new life. Now, Derek put together a comprehensive, it's a 20-minute video that provides do-it-yourself guidelines for adding an SSD drive and porting your operating system onto it. The end result will definitely improve your system speed. Terry, just give us short background to what people can expect from this video.
Hi, Johan. Yes, quickly. Some time ago, I did a presentation on the history of storage requested by you. And in that discussion, we referred to SSDs. And subsequently, I got a request from yourself to maybe just put together something to show the members what could be done, especially if you have an older laptop with an old hard disk, spinning hard disk in there. So what that video does is it basically shows you that you can buy an SSD, which is a smaller form factor than a normal hard drive. You typically, you can buy one of these units. It comes in a little box. Sorry, I think it's being blurred out there. And then inside the box, you find an item such as this. The SSD gets installed in here. You will see this unit itself has connectors on the back where it can connect onto the laptop chassis. And this then slots into the laptop in the place of your old DVD or CD drive, which nowadays are becoming out of use more and more. So this will allow you to add a second drive to your laptop. And it could be another hard drive as well, but typically people would put an SSD in here and then put the operating system on the SSD, because that's where you get the most speed benefits in terms of disk access. It is, however, fairly technical, and in the video I also allude to that. If you're not comfortable with it, rather get somebody that has good technical expertise to assist you. You can even ask a PC shop to do that for you. It will obviously be at a fee. But the biggest preparation in terms of approaching anything such as this is make sure that all of your data that you think you might need, if something goes wrong, is backed up and protected, whoever assists you in doing that. And that's all I have to say. The rest of the detail is in the video.